Hello everyone, welcome to today's tutorial. Today we are going to talk about Pandas, the powerful data manipulation analysis tutorial. My name is Asibah, a Python developer at the Python Lab. So in this tutorial, you are going to learn the fundamental concepts of Pandas, which is the powerful data manipulation and analysis library in Python. In this tutorial, I'm going to cover everything that you need to know to get started with Pandas. And I will explore data structures, create and manipulate data frames, clean and pre-process data, perform aggregation and analysis, skills for data analysis, and unlock the full potential of Pandas in your Python project. So don't forget to like, share, subscribe, and you can also ask your question in the comment section of this video. Okay, let's get started. Pandas is a powerful library in Python, which is designed for data manipulation and analysis. And it also provides an easy to use and efficient data structures and functions that can enable you to work with structured data effectively. So whether you are working as a data scientist or data analyst, you are dealing with a small or large data set of functionalities to handle common data related tasks. So one of the key advantage of Pandas is its integration with NumPy, which is another powerful library for numerical computing in Python. So this Pandas is basically built on top of NumPy, which is harnessing its computational power and extending it with additional high-level data manipulation capabilities. So the combination of Pandas and NumPy creates a powerful environment for working with data, allowing for efficient data processing, data analysis, and transformation. The most significance of Pandas in various data-related tasks cannot be covered in this topic, but some of the key areas where Pandas excels include like data cleansing and analysis. And the other concept I'm going to cover in this tutorial is data transformation and manipulation. And finally, I'm going to just show you how you can visualize your findings from your data cleansing and transformation tasks. Data visualization. Okay, the data cleansing and analysis basically provides the Pandas provides functions and methods to handle missing data, remove duplicates, handle data type conversions, and perform other data cleansing tasks. So you can just this stage is very essential as a data scientist and data analyst because the data may be not in a proper format. It needs to be cleansed. So you are going to just clean and analyze your data. You may need to remove duplicates. The data may be there are maybe missing data in your data. So you are going to just handle the missing data, and the type of the data may be indifferent. So it is not appropriate if the data, some data, for example, if the data contains a prices, so the prices should be either integer or floating point. So it may be in a string. So that data type is not appropriate for data analysis. So you are going to just convert into appropriate formats. Okay, the data transformation and manipulation essential. Once you clean your data and analyze, So you are going to just transform and manipulate that clean data. So Pandas offers powerful tools for transforming and manipulating your data. You can perform operations such as filtering, sorting, grouping, merging, and reshaping data. So it makes easy to tailor the data to your specific needs. The other is data analysis and aggregation. You may need to aggregate your data, so you may have different sources of data. So in some cases, you need to aggregate that data. Finally, once you just perform this tasks, you are going to just visualize your finding. The last stage of data analysis is visualize the findings and just understand the trends of your data set and understand the findings. Okay. Okay, let's get started. The first thing to get started in this data analysis with Pandas is you can choose your development environment. Actually, the powerful tool for working as a data scientist or data analysis is Jupyter Notebook or Jupyter Lab. You can also work on Colab. Colab is one of the best research tools for data scientists. So I basically use Colab. If you are connected to internet, you can just use Colab online. And you can also install Jupyter Notebook separately on your computer, and you can work on it. It's up to you. Once you choose your working environment, you can install the required install required libraries. For example, in this session, I'm going to install Pandas and NumPy. So the two you can use pip install Pandas and pip install NumPy. Thus, two most important libraries should be installed on computer. Actually, if you are working on Jupyter Notebook or Colabs, the two libraries are default. You don't need to install those libraries. But if you wanna just work without Jupyter Notebook, you can install independently. So you can use Python code instead of Jupyter Notebook, and you can install those libraries on your computer to work on data analysis. Okay, once you install on your computer, and the next stage is you are going to import those libraries for future use. So import Pandas as PD. You can short the long name. It is easy to understand, easy to use. So you can just name as PD, import Pandas. Instead of using Pandas, it is long name. So you can shorten that name using as keyword. And you can also import NumPy as NP. Okay, then you can run the cell once you import this. And next, I'm going to just uh, explain data structures in Pandas. Two data structures in Pandas. Data structures in Pandas. There are two data structures. One is Pandas data frame, and the other is Pandas trace. So you have to understand the data structures in Pandas before working on your project, okay? So those are the basic common types of data structure in Pandas, data frame and series. What are the difference between the two data frame, I mean the data frame and Pandas series? A series is a one-dimensional labeled array capable of holding data of any type. dimensional array. It is similar to a column in a spreadsheet. For example, in Excel spreadsheet, it is similar to one column of that spreadsheet because it is one-dimensional, or a one-dimensional NumPy array. It is similar to a one-dimensional NumPy array. And a series consists of two main components in Pandas series. One is the data itself. One is the data itself, and the other is a set of index labels that uniquely identify each element in the series. So those are the two main components in Pandas series. So you have to understand the two main components in Pandas series before working on it. So these are the data itself, the one-dimensional array, and the set of index labels which uniquely identify each data in the series. Okay. I'm going to just demonstrate different methods to create a series in Pandas. I have already imported the library here, Pandas, and I'm going to just show you how you can demonstrate, how you can create a series using different methods. So, for example, you can create Pandas, creating a series from a list. So if you understand how to create a list, you can just create PD series, PD dot series. This is the method used to create a Panda series. Then we can pass a data into this function. For example, I'm going to just pass a list 1, 2, 3, 5, and NumPy. Basically, it is used to just create a NumPy. For example, NP none means just there is no data in this case. It is missing of that element. It is not a number, which means more 8. So this is a list. So you can create a series using a list. Let's run this code and let's see what are the basic components. As you can see, on the left side of this data is the index of the data, which identifies the elements, the position of the elements in the series. So it starts from index always starts from 0 up to n minus 1. Okay. So here the data is in the right side of this, which is displayed. So this data frame, I mean the Pandas series, as you can see, contains two components: the data itself on the right side of this output, and the left side represents the index of each data pointers in the series. Okay, this is the way how you can create series. This is, as you can see, this is a one-dimensional data. Only it has only one column in this data. Okay. The other way how you can create a series is from NumPy array. You can create a series using NumPy array, creating Panda series from NumPy array. So first of all, we have to define the NumPy array. np.array, and we pass the array 1, 2, 3, 4, 5, 6, and then the trace, we can just create pd.trace, and we pass that array into this trace. Then we can run and we can see the output. The output is the same. It's just it has index label and the data label. It only consists two components. The data label is a one-dimensional array, and the index which identifies each data pointers in this arrays. And the third one, so you can also use dictionaries to create. The third one is first creating a trace from a dictionary. Let's define the dictionary first. Let me A1, B. Okay, now I can just pass this dictionary to the Pandas series to create Pandas series. And let's see the output of this race. Okay. Yeah, in this case, the index representing the keys from dictionary. It is different from the other series. In the above series, for example, creating a series from list, which creates automatic indexing system. But here, the dictionary keys are the index of the series when you are creating a series from a dictionary, because each key identifies the data pointers in the series. The other thing, you can understand what type of data you are creating, and automatically detects the type of your data. For example, in the first, it is just floating point, automatically converted a list values into floating point. It is normal. And the second one, which is created, a numpy array always understand numerical data. Okay, here is, for example, if you do not specify the type of the data here, automatically this is integer. And the third one is also it is created from a dictionary, which is integer. Okay, so in this example, I created a series with values using different methods, using list, using numpy array and dictionary. So the series automatically assigns an index label to each value. Actually, in the dictionary, which automatically assign the key value, the keys as a index in the Pandas series. So starting, for example, in the above, the indexes are starting from 0 up to n-1. If you are creating your a series from dictionary, the keys are automatically assigned as an index level in the Pandas series. Okay. The second step, once we create our series, which is a one-dimensional data, we can access and manipulate our data in a series. Okay, let's let's accessing and manipulating data in a series. For example, if you wanna just access uh, 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 the series, let me change this. A simple way is this one. Okay. Let me take this an example, and let me show you how you can access element. For example, if you wanna just access the first element in the series, you can just pass index into this PD underscore s, which is the variable name of the Panda series, which holds the list of elements, a series of elements. So I just pass index 0, which gonna access the first element in the series, and it will show you that is 1. And if you wanna just access the elements from third row, third row up to uh, the last, you can use PDS. For example, third is 0, 1, 2, 2 up to, then you can run this code, and you can read all the elements starting from the third element. 0 is this one, index 1, element 0, 1, 2, 3. So it is just starting from this. You can slice. Actually, it is similar to list slicing. So if you are familiar with list, it is similar with that. You can work on, and you can also work performing some operations on SRS. For example, if you want to add 10 on each values of the series, you can use s plus, for example, plus 10, and you can check that. I mean, let me the series I should assign to, yeah. So each element, I have added 10 to each element in the series. Previously it was 1, 2, 3, 4, 5, 6, and now after added 10 to each series in the each element in the series, it just changed to 11, 12, 13, and so on. You can also find the average using mean. It supports a mean, and you can use s dot mean, which is a built-in function. Mean basically to just calculate the average of the series. Okay. You can, instead of this, you can use sum the series divided by the length of the series. Yeah, the result is the same. First, you just sum up all elements in the, because it is average, and once you get the sum of the elements, you can divide to the total number of elements in the array. And instead of using this, you can use mean. Okay. So this is basic examples. You can work more about Panda series, and the key pointers in this series is don't forget that it is a one-dimensional and can hold on any data type. Here I showed you integer data types, but you can store any types of data in this arrays. Okay, so you can store integer, floating point, string, etc. It has both the data and the index levels. So always it has two components: the index level and the data pointers. and it allowing for easy and efficient data access, and serious operations and computations are aligned based on the index levels. So you can perform any computational or any computation using the indexes. It's like list. Okay, now I'm going to just start data frame. Okay, a data frame is another data structures in Pandas. Uh, this is different from a Pandas series. A Pandas series, basically, as I've told you, it is a one-dimensional uh, data, which is similar to a one-dimensional array, NumPy array. But a data frame is a two-dimensional label data structure resembling a table or a spreadsheet. For example, a spreadsheet or a table contains two-dimensional array or two-dimensional data, which are in the form of columns and rows. So it is consists of rows and columns, where each column can hold different types of data. And a data frame provides a versatile and efficient way to work with structured data. So this is basically different from Pandas series because data frame is a two-dimensional, uh, which contains two-dimensional data, like which consists of rows and columns. It is similar to a spreadsheet. So it provides a versatile and efficient way to work with structured data, basically structured data. Now, the next step is just creating a data frame. Like creating a Pandas trace, you can use different methods to create a data frame. The first method is creating a data frame from a NumPy array. First, you have to define the NumPy array, NP array. And for example, it is a two-dimensional array for 1, 2, and the other dimension is 3, 4, is 5, 6. Because it is two-dimensional array. It is not one-dimensional array. Now, let's create a data frame, and we pass the array into the data frame. Instead of trace, we use uh, data frame, and we pass the data into this data frame function, and we also pass columns for our data frame. It's, for example, A and B columns because it is basically consists of columns and rows. The rows are already defined, the data. The rows are the data, and the columns are the fields which identifies the data pointers in the data frame. Now let's run this and let's check our data. Yeah, it consists of two columns and three rows. Three rows. The first row, 1 and 2, and this also has index labels, automatically assign index labels to the data frame to identify each rows in the data frame. Okay, this is one way to create a data frame from NumPy array, and the other is you can load your data from CSV. If you have a data in Excel or CSV, you can load data from a CSV, which is a comma separated file. Uh, yeah, mostly we store our data because we may have large volume of data. So we store that data in CSV, and we load that data from CSV using, for example, pd dot read CSV, and we pass the path of the data. For example, yeah, basically it is good to store the file of that CSV in the same directory of your code. So this is the way how you can create. Right now, I don't have a CSV file, so this is the mechanism how you can read data from a CSV. Okay, let's go on. And the other is creating a data frame from a dictionary. This is one of the most efficient way to create a data frame from creating data frame from a dictionary, because the keys and the data pointers are already defined, so you don't need to just pass the columns in that data frame. Okay, let's define that and let's see. First, you have to define the data. For example, name, which contains list of name, as Siba, Charlie, and the other the other column is H column, and H column uh, basically like 25, 30, this sample data. It must be the same length. Okay. Now let's define. Let's create data frame. B dot and pass the data, the dictionary data into this function. Okay. Now let's run this code and let's see our data. Yeah, the columns are the keys in the dictionary, and the values are assigned to each column. Okay, this is another way how you can create a data frame using from a dictionary. Okay, so in this example, I have just created a data frame with two columns, name and age. Each column represents a series, and together they form the data frame. So each column basically just represents a series, a Pandas series. For example, if you want to just access this df name, just returns a series. Yeah, a series. So you can also obtain a series from your data frame, because a series always consists one dimensional uh, data. So one column in a data frame is a series. Okay, this is another way. Now the next step is I just want to show you accessing and manipulating data in a data frame. So I'm going to just focus in the data frame. For example, here I have just showed you how you can access the name. You can just pass the column name in the square brackets of the df. df is a data frame, the short name of data frame, which stores the data frame in this variable, and you can access any columns using the column name. Okay. For example, if you wanna just access age and name at the same time, you can just pass list name edge. So you can get data frame. You may have different, more than one, two columns. So in this case, I have already two columns. That's why this way is just creating another data frame. This way is just creating another data frame. Okay. For example, if you wanna just the other is filtering. How can you just access? If you wanna just access edge greater than 30, you can use def edge, which is greater than. You can apply any conditional statements or any logical statements, which is greater than 30. So if this condition inside this data frame, this condition is true, the result is true. For example, let me first just edge greater than 30. The result would be either true or false. So in the first row, edge is not greater than uh, 30, which is below is true. So because I greater than already, if I put greater than or equal to, it could the second row could be okay. Yeah. So this is the condition because this is condition. If age is greater than, I just perform this condition if age is greater than or equal to 30, and I wanna filter the exact rows which age is greater than or equal to 30. I can pass this because based on the condition, I just filter through only rows from the data frame. Yeah, only the second and third rows are filtered from our data frame because 30 is greater than or equal to 30. 35 is also greater than or equal to 30. You can also apply any computation, any operation. For example, if you wanna just add, uh, for example, age plus 5. If you wanna just 5 in each piece of age, you can use like this. So age now, for example, the first one was 25, but now it is 30, 35, and 40. Okay, and you can find the mean of age dot mean. Okay, now the mean of age is 30. Okay, step in this tutorial is data cleaning and pre-processing. I'm going to create a new data frame. I'm going to just create or generate synthetic data to work on data cleansing and pre-processing stages. Okay, in this case, let's create uh, generate sales data. First, generate categories. For example, electronics, clothing, uh, sorry, the inconvenience, and books. Those are the categories. I'm going to just create, generate sales data. Now let's generate. Okay, sales. I just use random data, random from NumPy, int 100 to 1000, and the size is 100. In this case, I can in the type as type to float. Yeah, basically it is price data. So sales data may contain floating data. Now let's fill the at least 10 rows with missing data to work on data cleansing. Fill at least 10 rows with none. Dot a number. Dot random with range 100. Size is 10. And replace with force, which is equal to np dot none. Okay. Okay. Now let's generate the data frame with data frame. If is pd dot frame, I can pass category np dot random dot choice. I just assign the categories randomly to the sales data. That's good practice because because I'm going to just create random data categories, and which is the size is 100. Okay. Okay. Now let's define the okay. I just miss the sales. Sales here. Sales. Yeah, exactly. Here is the data I have created. It contains 100 rows and 2 columns. The category sales columns. So the categories are randomly assigned to sales data. Okay. Now, just exploring the data, I have just explored the data here. Uh, uh, the next stage is just I can start uh, getting, and I mean, working on data cleansing, or I mean, we can use different methods to explore the data. For example, from 100 rows, you may have thousands or millions of data. So you have to just first explore the head, first 5 rows from the data frame, okay, to easily understand that use method. You can also just explore the tail, which means the last 5 rows from your data set. You can simply understand the nature of your data, the distribution of your data. Okay. Now the last 5 rows are just explored using tail method, and the other is info. If you get basic information about the data frame, you can use def dot display the information about your data frame. So the information is here are the indexes, the total number of entries here, 100 entries in your data frame, and the indexes are from 0 up to 99, and the data columns are there are 2 columns. Uh, the columns in this and null count, uh, and the other is the data type. For example, category is object, which means a string, a text, as you can see, and the sales data is floating. So you can just understand the informations about your data frame using info method. And if you want to just understand the statistics of your data frame, you can use def.describe. This is another method. You can just understand. For example, here the count is the total number of sales, 90. The sales count there is 90 because 10. There are 10 rows which are missing data pointers in the sales. The mean of this data frame, the sales data frame, only actually it is the describe because it is the summary of statistics. It is working on the numerical data only. The objects cannot be displayed or described in this case. Okay, the standard deviation, the minimum value in the data point in the sales data point is 105 minimum value, 25 quartile, 50th quartile, 75, and so on. And the maximum is 999. Okay, this is a statistical summary of your sales data. Now, the next step is data manipulation is very important. Once you understand the nature of your data by exploring using these methods, describe, info, tail, and head, you can now work on data manipulation. So Pandas allows you to manipulate and transform data easily. So I'm going to just show you some common operations you can perform on data frame. Okay. The first one is selecting columns. For example, let me select the category, okay, and okay, you can select and you can get a trace. Okay, actually, if pass like this, it is a data frame. If without, if you pass without, uh, because that is representing a two-dimensional array. can get the series. Okay. Yeah, series. And if you wanna just filter the cells to understand, you can filter cells. Cells data, which is greater than 300. Okay. Okay, sorry. This is what. Here is the data frame. I just forget that. Okay. Yeah. Just filter the data. The sales data is the values of the sales data is greater than 300. So you can filter look like this. And the other is sorting the data. You can sort the thing or descending order. Uh, Sorting sales data. Df dot sort values of that column. You can pass the column name in that function, and it just sorts the data. In this case, it just sort in ascending order from uh, minimum to maximum. Okay, and you can add a new column into this data. For example, if you want to add the mean of the sales data, sales mean, you can use like this and assign the result of the sales mean. And you can see that by running this data frame again. Yeah. So the mean is just it is common. Yeah. The mean of the sales data is uh, like this. And now let's understand the shapes of the data. Actually, you can understand the shape of the data by looking at the below of the data frame. It is 100 rows and 3 columns. And you can use f dot shape to understand the shapes of your data. So you have 100 rows and 3 columns in this case. But I don't want uh, this. So I just rerun okay, the original data, because I don't want the sales column, I mean the mean of the sales column right now. And I just understand the shapes. Right now, I have 2 columns and 100 rows. Okay, this is the shape method. The other is, so I just, in this example, I just generated 100 sales data using random numbers. However, I deliberately introduced 10 missing data pointers at the randomly by assigning np.nan to those positions in the sales array. Now let's explore the common data cleaning and pre-processing tasks to handle the missing data. Okay, let's data and the sales data. You can use is none method to check the missing data in your data. In this case, it just return true or false, but I just wanna just sum up how many missing data I have in the data frame. Okay, in the category, I don't have any missing data, but in the sales data, I have 10 sales data are missed up. So I'm going to just either fill, remove this missing data, because it is not, if there is a missing data in your data set, so that missing data is not uh, uh, important in your data. That missing data is incorrectly recorded data. So you have to fix that missing data to get uh, best insights from your data sets. Okay. So now let's removing rows with missing data. For example, let me removing rows with missing data. Remove rows if remove removed if dot drop na. You can use drop na from your data frame, and you can understand def removed. Okay. Now, previously I had 100 rows and 2 columns, but right now, after removed or dropped the 10 rows from the data set, which are not a number or missing, so now I get 90 rows on a tree. Okay, this is one way to remove or drop, but there are different reasons to uh, 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 just remove or drop your rows. If you have a small data set, be careful before removing your data points from your data set. Okay. Okay. Now let's filling missing data with a specific value. For example, if I wanna just miss the missing data with 0, because none values could not be analyzed. ስለዚህ I should just fill is 0. 0 f dot fill na. Then I just put any number. Actually, not only 0, you can put any number. Fill is okay. Now I just get 100 rows because all the missing data are filled with 0, and I can understand that uh, uh, the is null. Let me check. Is there any missing? Right now there is no missing data because all the missing data are 0.0, which was missing data, and it is filled with 0. This is another way how you can just fill the missing data with a specific value. Specific value. Okay. There is also another way, especially if you are working large data sets. So you have to be careful before filling your missing data. You may need to fill the missing data with mean or median. Okay, so you have to understand the nature of your data and the distribution of your data. You may need to just plot the distribution of your data using different distribution methods. So I will not cover in this session. Okay, now fill missing data with a mean. First, I just uh, get the mean of the sales data. using min method. Sales data. The mean of the sales data is 510, 510.3 something. Okay. Then I just fill the missing data with this value. This is another method. But there should be a condition why you need to fill the missing data with mean or median. Now let's if mean field, if fill NA, and you can pass the means you obtained from your sales data. Okay. Now, as you can see here, previously it was 0. Now I just filled with mean values of the sales data, and it is now 510. Okay. So there is no missing data in this case. You can perform median and other techniques. This is one way of filling the missing data. So in this example, value with the mean or any specific values, or I just dropped the missing rows. So you can perform one of the methods to handle your missing data. So these are just a few examples of how you can handle missing data using Pandas. There are other techniques include interpolation, forward or backward filling, or advanced imputation methods. If you are working on machine learning, so you may need to use advanced imputation methods. So it is up to you. If you understand how you can fill the missing data, you can go for these methods. The choice of method depends on the nature of your data. As I have told you in the previous uh, example, so when you are filling your missing data, first you have to understand the nature of your data set. And you have to just methods to fill your missing data, okay? And that's data cleansing and pre-processing tasks are essential for ensuring for further analysis. So Pandas provides a wide range of functions and methods to handle your missing data, as I've showed you here, and other data cleansing tasks efficiently, making it easier to work with real-world data set. The next step I'm going to show you is, so let's save this with the original data. Okay. I'm going to use this as the mean is already filled here. Okay. Data aggregation and analysis is very important. Once you clean your data, pre-process your data, you have to just aggregate the data. For example, in the category, I have different categories. I should just group the categories and count the number of sales data in each category. So data aggregation and analysis techniques is very important for data analysis. Now let's grouping data and statistics. First, let's apply def group. There is a def group method, group by method. By what column you are going to just group. In this case, I have categories, books, electronics. So I'm going to just group the category columns. So I just pass this group by category. And I just, for example, if you want to find the sum of each group, the total sum of sales data in each group, for example, in books group, you can just apply this sales. And finally, apply sum. This is the way how you can group your data. This is the way how you can the books category, the sales of the total sum of eight. The closing is also here, and this is the way how you can group and calculate the sum of each group. The other is you can also uh, the group by category, and you can find the sales, the mean of the sales data in each group. This is the mean of the data, and this one is the sum of each category, and this is the mean of each category. So it's mean of data aggregation and statistics. Apply a custom function to perform this. For example, custom function if custom functions x is the data frame, and it's going to return x dot mean minus x dot mean, which means the max. The mean is maximum minus minimum. Now let's group that data and category and sales data. Then I can use apply function in this case. Then I call the custom function I defined above. Okay, let's run and let's see this. Yeah, it is this one. This is the way how you can apply the custom function. Okay, and the last one I'm going to show you is a data visualization. Once you perform the data aggregation and data pre-processing or data cleansing stage, you can go for data visualization to understand the trends of your data set. Highlights Pandas integration with visualization libraries like Matplot. You are going to just import Matplot library from Matplot lib, import iplot as PLT, and you can also import Seaborn, which is another data visualization tool, which is built on top of Matplot lib scene. Now, if you want to just visualize a scene, bar plot, the data is the data frame. You can pass the data frame to the data point, and in the x, you can represent the x and y axis of the plot. For example, in the x, the category columns, and in the y is representing the sales. And you can apply category of each. Okay. Okay. Sorry. Yeah. and you can apply reality.show to show you the graphs. Yeah, this is the categories of your, each categories can be floated, look like this, and the right and the x of this category data, which is the category, and in the y is the series of each category, and this is the legend of the category. You can apply titles and other uh, uh, data visualization, though I'm going to just can visualize your data set. So this is the basic, the fundamental concepts of data manipulation and data analysis using Pandas. So a data frame is a tabular data structure with labeled rows and columns. It can hold heterogeneous data types. It can hold different data types like string, floating point, date type, or any heterogeneous data types in different columns. So a data frame allows an easy data manipulation, filtering, and analysis of data structures. I have showed you in the above examples, and it also provides a variety of functionalities for data cleansing, data pre-processing, and aggregation, and more. I hope you have enjoyed in this tutorial. So this is the fundamental concepts of data analysis with Pandas tutorial. Don't forget to share, like, and you can also write your comment in the comment section of this tutorial. Thanks for watching today.